we are introducing two independent variables. And we still have our three equations. We have V final is equal to V initial plus acceleration times time. We have V final squared is equal to V initial squared plus 2 times acceleration times my change in position. And we have my change in position is equal to the initial velocity times time plus 1/2 the acceleration times time squared. Now, I have motion in the x direction and I have motion in the y direction. And in the motion in the y direction, we have my acceleration due to gravity, which is going down. And so I have that in the equation. And if I have this situation where I've got a plane flying horizontally, and it's going to want to drop some water onto this target here. And we want to make sure we hit the target, because if we're doing this for wildfires or something like that, we want to make sure that we're going to hit the target. Now, we're starting to deal with the motion in the x direction is independent with the motion in the y direction. So my initial velocity, if I'm going to actually write it out in vector notation, my initial velocity is only in the x direction, and it's 180 meters per second in my unit vector in the x direction. But I have no velocity in the y direction. It's just going to look like I'm dropping the ball off at the top of the roof. Now we know that the motion of this object, because we've seen it in other things, we've seen it in demonstration, that the motion is actually going to be some sort of parabolic motion that we have out here. And we want to make sure that we hit the target. So we've seen in a couple of videos that if I drop a ball, it's going to hit the ground at the same time as if it had some sort of y motion. So the time for this is going to equal the time for this, and t1 is equal to t2. Well, I've been given the height that it's going to fall. I've been given the initial velocity, but I haven't been given the distance, nor have I been given the time of fall. So I kind of have two different variables, the time of fall and the distance. So I'm going to have, if I have two unknowns, I'm going to have two independent variables or independent equations to solve for those two independent variables. And I do have independent pieces of motion here. So the first thing I want to do is I'm going to solve for the time of fall. All right. And to do that, I have the change. I've got a change in position. So I have my change in y is equal to 1,800 meters. So this is kind of my x when I'm looking at my three independent equations up here, my three equations that I'm going to use. I also have my initial velocity is equal to 0, and this happens to be in the y direction. I have acceleration. I know what acceleration is. It's a negative 9.81 meters per second squared. So I have acceleration, I have initial velocity, I have my change in position. What I don't have is time, nor do I have the final velocity. However, I can look at this and go, oh, well, look at here. I've got my change in position. I have my initial velocity. I've got my time. So let's do this. Let's write it in terms of y. We know our initial velocity, and we know we've got 1/2 my negative g times time squared. So my change in position is going to be my negative 1,800 meters. Our initial velocity is 0, and I have minus 9.81 divided by 2 times squared. So let's go ahead and solve for t squared. T squared is going to equal my 1,800 times 2 divided by gravity. And this is in meters divided by meters per second squared, which is going to end up giving me second squared, which is good. That's exactly what I want. We can plug that into the calculator. This is going to give me 367 seconds squared. Take the square root, and I have the time. So I've got 19.2 seconds. So the water is going to take 19.2 seconds to fall down. But I want to know how far away from the target do I have to be before I drop my payload to make sure that I get the target. So now I'm going to be looking at my change in X position. So that distance is going to be equal to the velocity in the X direction times time plus 1/2 the acceleration in the X direction times time squared. Well, we have no acceleration in the X direction, so that's going to go away. And now I'm just going to go in and solve for my 180 meters per second times the time that we found for what it takes to fall, 19.2 seconds. And now if I plug that into the calculator, this is going to be, I need to drop my water when I am 3,448 meters away from the target. So this is going to be 3,448 meters. That's the distance away from the target that I would need to drop it. And the time that it takes for it to fall is going to be 19.2 seconds. So I'm going to use my equations of motion. I'm using the fact that my X direction is independent of my Y direction, and I'm going to be able to hit the target.